ಚಾರ್ಜ್ ಇಲ್ಲ ಏನು ಹ್ಞೂ ನಿಂಗೆ ಹೋದಲ್ಲ ಅದು ಇಲ್ಲ ಮತ್ತೆ ಬೇರೆ ಹಾಕೋದು ಮತ್ತಕ್ಕೆ ಓ ತಳಿ ನೋಡಿದೆ ಎಷ್ಟಿದೆ ಅಂತ ನಾಳೆ ನಡೆಯಿತು ಓಕೆ ಡನ್ ತರ್ತೀನಿ ಹಾಗೆ ಇದು ಹಾಂ ಡನ್ ಡನ್ ಯಾಕೋ ಬರಲ್ವಲ್ಲ ಹೆಚ್ಚು ಮಾಡ್ತಾ ಹಾಂ ಡನ್ Sorry for the late. Yeah, in the previous lecture, I told about lean management framework. So having all these 5 components: stability, standardization, just-in-time, Jidoka, and involvement. So I will continue the same PPT today. Okay, basically that lean management system consists of 2 pillars. So TPS is built on 2 main pillars. One is just-in-time, and second is Jidoka. So these 2 are called as pillars of TPS or pillars of lean manufacturing. What do you mean by just-in-time? It refers to the manufacturing and conveyance of only what is needed, when it is needed, and in the amount needed. Okay, you can say it in a simple term. You can call it as zero inventory. Nothing to store. You buy as and when required. Okay, that's why you can say it refers to the manufacturing and conveyance of only what is needed. Okay, normally what happens in traditional inventory system, they're going to keep more inventory, whether required or not, keeping in mind the entire requirement for entire year. So, or even for sometimes they're going to have buying contract for once in 2 years. Okay, so they're going to keep inventory, whether required or not. So keeping inventory creates lots of problem, you know it. Okay, requires lots of warehouse space and accumulation, wastage, damage, theft, and suppose environmental this is also going to spoil the materials also, like rust, dust and all. So normally there's going to be so much of wastage when you're going for a traditional inventory management system. That's why just-in-time is a concept where there is no inventory. You can say zero inventory. So here, the important point is the supplier should be reliable, because any supply of raw material or machinery, equipment, or you can say entire manufacturing activity depends on supplies only. No material, no manufacturing. No machines, no manufacturing. No tooling, no manufacturing. So, for everything, for any manufacturing activity. So, suppliers are good, reliable, they supply in time, then of course it's possible to start any manufacturing activity. So, I prefer to the traditional people think that, so when suppliers are not reliable, when transportation is not reliable, then they have no waste, so they have to store more inventory. So this just-in-time concept, okay, it's a basically Japanese concept or idea or ideology, you can say it. So they say that there is nothing to keep as inventory. Nothing we can say zero inventory. Just in time, okay, buy when you require. It refers to the manufacturing and conveyance of only what is needed. What is needed now? What quantity required? What machine required? What equipment required right now? Okay, so you do not bother about for next year, 6 months, or next quarter and all. So what is required right now, and when it is needed? Okay, when exactly you want? Okay, means whether after completion of this component manufacturing or machining of this component. Okay, say for example, normally in case of assembly works and all, nothing to keep all the items required. There are some items they require only after completion of entire base things have done, like a framework, chassis, everything done. But then they're going to fit the small components and all. That time they don't require. So they can buy at later stage. So that is only what is needed, when it is needed, and the amount needed. It is quantity. Okay, how much quantity? Instead of buying for just to take the advantage of discount and all, buying bulk, buying the large quantity, it's of no use. I told once again leads to so much of extra inventory. So essentially they're going to buy how much they require. Okay, quantity. So just in time is focusing on how much and when and where. Okay, so it is what is required, when it is required, and how much required, quantity, time, and these things are nothing but just in time. Okay, refer to the manufacturing and conveyance of only what is needed, when it is required, and the amount, quantity, how much required just in time. So manufacturing. Second, Jidoka. Okay, it's one more a new term launched by Japanese. Okay, Jidoka. Jidoka, the ability to stop production lines in the event of problems such as equipment malfunction, quality issues, or late work. Jidoka helps prevent passing of defects, helps identify and correct problems areas using localization and isolation. Okay, something that error-free manufacturing. Okay, we can say it, send in the zero defect product. Okay, that is we can say Jidoka basically the ability to stop the production lines in the event of problems such as equipment malfunction. Okay, you know it, traditionally you know it. That is the quality of the end product depends upon the machines. That is machining, the accuracy, precision, dimensions, or anything which is quality of the complex product. It totally depends upon the process it has undergone by a machine. Suppose the machine is malfunctioning, say suppose some sort of vibrations or maybe that the machine is not perfectly operating, lots of interruptions are going to be there, then of course they're going to affect the quality of the end product. So that is in the event of equipment malfunction, quality issues, sometimes they're going to fix some say level. Okay, any product manufactured, okay, if which is going to be within this level, then accept it. If it is beyond level, okay, it's rejected. Just like in quality control, we call it as upper control limit and lower control limit, LCL and UCL, wherein any components are lying within these values, average values, upper control, lower control, are accepted. If any products which are going beyond the levels, LCL or UCL, upper control limit or lower control limit, they are liable to rejection. So there are sometimes, so they're going to fix some quality standards. So any product manufactured should be within that limit only, okay, within that quality standard only. If not, they reject it. I think just like what long time they used to go for go gauge and no go gauge. Okay, a go gauge and a no go gauge. Okay, just like for example, if you want to if you want to accept in the lot, we want to, for example, we have some components. We need this much thickness, for example, 5 mm, and 0.05 millimeter and all. Okay, so just they're going to make on gauge and pass the component. If it goes, that go gauge passes, accept it. If not going, reject it. So normally this to go for. So there are sometimes there are going to be some sort of quality issues led to acceptance or rejection or late work. Okay, sometimes they have to postpone the manufacturing. Okay, for example, they have lots of work in progress, WIP, lying in a workstation. Next workstation is not ready for accepting the next work in process product component and all. That time, of course, they have to stop. They have to stop one particular section. Okay, this workstation is completely filled with lots of WIP that is going to cater to the needs of around another 2-3 days. Then 2-3 days they have to stop late work. So there are sometimes it's the ability to stop production lines. Okay, at that time. So because of some malfunction of the equipment, or maybe due to the quality problems issues, or maybe sometimes they are forced to start late work, or sometimes in the beginning only they might have started late. Okay, those things are the ability to stop production lies in the event of problems like equipment malfunction, quality issues, or late work. Jidoka helps to prevent the passing of defects. Okay, remember it is going to prevent the passing of defects. Remember, that's what we say, Six Sigma. Okay, one defect out of millions of components manufactured. No one wants, nobody wants a defect product. Whether you are going to accept any component, for example, even when you're going to buy a automobile, so for example, a bike or a car, when you're going to buy a car worth of any lakh, maybe 5 lakhs or 10 lakh, doesn't matter the cost of product. For example, if you feel any small dots in the main body of the car, you are going to say it's a defect you feel. Okay, you don't like it. Let the dots or any scratches may appear later when you're going to buy it, often after buy it. But before buying, you're expecting that I don't want to have any scratch or a dots on a car body. For example, same thing. Okay, suppose something, one thread also coming out of this shirt, I don't accept. Okay, I feel that it's a defect, means they are unable to stitch properly. So, but when I purchase, after giving for washing, okay, suppose it's going to some threading coming out, so you can't blame anybody. So it's very important for any organization. So they have to make sure that no product or any product goes with not even a single defect in terms of anything. Okay, the Judoka helps prevent the passing of defects, helps identify and correct problem. It's also very important. Okay, what is the defect? It's not only not sending the defect product, but also there are sometimes like it's not fitting properly. Say for example, a component has got multiple number of drilling holes and is supposed to be kept on some of the component where we have the holes. And suppose this holes and that was not matching, even one small, even one of the among the 10 holes of the drilling holes is not matching, it could become defective one, Okay. So it's very important that identifying that what is the defect. Okay. Not only identifying but also correcting it. Okay. Correcting it means at any point of time when it comes to gone to customers, so the defect should not be there for the product which are sent for the customer. First, identify areas using the localization and the isolation. Okay, that is what we call as Judoka. Means at the end, what I said, it's not allowing any defect component to go out of the organization. Okay, that's what the Judoka. That's why these are called as the two pillars of TPS, just in time, and Judoka. Okay, so I have understood what you mean by Judoka and just in time. Next, yeah, you just see some graph here. Lean has been adopted in many different environments since its creation. Okay, so people have got some wrong concept that lean manufacturing. Okay, lean is only for manufacturing organization. See that since the inception of this adoption of this term lean, so it is adopted in many different environments. Okay, you can see that. You can see that it's going to be almost all the areas covering, lean is covering almost all areas. Okay. So, say for example here, okay, consulting services, hospitality services, retail store, ITO and BPO, banking, airlines, railways, insurance, law, hospital, novel operation and maintenance. They all service sectors, upstream, E&P, chemicals, pharmaceuticals, pulp and paper industries, food processing industries, okay, high-tech organizations, aerospace, consumer goods, shipbuilding. Okay, so these are all oh yeah, also you can say it, it's a graph is there here, so what you can say it, I'll show you that graph correctly. Yeah, oh sorry. Yeah, these are the three industries. Sorry, I'm unable to show you that entire PPT because some problems here. Okay, so these are the three sectors. These are you can use lean manufacturing. These are the processing industries. That is chemicals, pharmaceuticals, pulp and paper industries, food processing industries. They are the processing industries. Shipbuilding, aerospace, high technology, those are all manufacturing organizations. So lean can be applied for various sectors, maybe manufacturing or service sector or processing industries. Okay. Say for example now, one example take for example here, banking, let us say, in banking, how this lean manufacturing is used in banking. Uh, Say for example, I think you don't know about the working of banking, how it was previously. Say for example, maybe before this, all these single window concept come into effect. So previously, say for example, you want to buy, you want to purchase a DD. Okay, say for example, you want to apply for a job, and you want to buy one DD for along with application of 10 crores a DD. Okay, so typically you have to go to that counter, then ask for the form. One person is to be there, a peon is to be there, is to give one form for apply for DD, and you're going to give it to him. Then they're going to write the amount, that's how much exchange amount, how the amount to be destined to mandal. Then you have to go to that counter, pay the amount, give back to one clerk. Clerk is going to posting somebody. They used to say, that, okay, you are given in the morning now, come after 4 to 5 hours. So to take a single DD, if you go at 10:30, 11 o'clock at the bank, so you may used to get after 3 or 4 o'clock. Means they're going to be 4 to 5 hours to take a single DD for applying for a job, say. So that time there are going to be so many people involved. One, that peon is to collect that form, giving to one clerk, clerk is to check, and next one person is going to prepare DD, and somebody person going to take money from the account some section, and then once again coming back to this one, they're going to put some punching and all, sign it, verifying it, and then sending it to some clerk. Then I am going there collecting at the dispatch section. So there are a lot many people involved for a single DD. Now single window concept has come, wherein directly you are giving the form to the account section, and account section they're going to collect the money, okay, or even of course somebody's card systems are there, okay, plastic money, just swipe it, then they're going to check out, immediately print, and giving immediately to the next person manager, sign it and giving. So within, I think you don't have to wait till the afternoon. It's maximum 30 minutes you are going to get a DD. A single window. That is lean manufacturing. That is, okay, so when the same DD is to take lots of time and more people involved, but here hardly only one or two people involved in getting a DD. So that's why you can say lean manufacturing. Lean is a philosophy. Okay, it is a philosophy. It can be applied to service sector or processing industries or manufacturing. Okay, just to eliminate the call as some wrong concepts that lean is can be applicable only for manufacturing. Okay, it's not a wrong concept. It can be applicable to service sectors, processing industries, and manufacturing also. Okay, you can see here what does lean in manufacturing and the process industry look like. Okay, just see this here. Okay, it is how exactly that lean manufacturing is applicable for process industries as well as other manufacturing organizations. Say here in automotive industries, lean manufacturing is used for one, inventory reduction, second, production. Okay, production and inventory management. What are the common issues here? Normally, in manufacturing scenario, organization, throughput, equipment downtime, rework and re-inspection, and inventory costs. Okay, normally the issue of delays, okay, lead time issues, and downtime of equipment, okay, malfunction, and the rework and the reinspection sometimes, so due to wrong usage of designs or even unskilled laborers or some machine or equipment transfer, so maybe end up with it's not properly manufactured. So there's a need to go for once again rework or reinspection. And inventory costs, I told that they don't use just-in-time concept, then then they have to go for inventory only, so, having more inventory or more buying more quantities. They are the common issues in any organization: throughput time, equipment downtime, rework and reinspection, inventory cost. So typical solution, okay, typical solution. What suppose this is a problem of throughput time problem. Okay, then what is supposed to? Then they have go for one piece flow, okay, or full system. Let one piece flow only. That is at a time, one piece flow or full system and all. Second thing, suppose if equipment downtime, then what they have to do? Then they have to go for equipment reliability. Okay, lots of maintenance issues are there. Okay, one of course, the best thing is that preventive maintenance. Okay, by having preventive maintenance concept and all, okay, so they can improve the equipment reliability. So that that issue can be solved by having a proper maintenance program and all. And rework and re-inspection is one more common issues in manufacturing. Then what is the solution for this one here? Elimination of defects. Okay, there are some people they said do right at first time. Okay, do right at first time. That is, don't give any scope for rework or re-inspection. Any component manufactured in a single line should be a quality product. No rework, no inspection. Okay, that much of guarantee the system should provide. That much of guarantee the skill worker should provide. That much of guarantee part should come out of because the process or the method adopted. Okay, so it's very important that, okay, so elimination of this is very important. Okay, so the third point is that is elimination of defectives. That is, the issue is rework and inspection. Inventory cost. So go for, it's a common problem or common issue in organization. That is inventory cost. Then what they have to go? Go for inventory optimization. Okay, inventory optimization. Nothing but I told just-in-time concept. Don't go for buying extra. Okay, you buy how much you need and when to need. So quantity and the time should be correctly known. Then you can go for optimizing the inventory. So these are some of the common issues normally in manufacturing, and this is a typical solution for these issues. Say, for example, the common one more sector, aerospace, wherein you have in-person apply for engine overall or spare parts. Okay. So what are the common issues in aerospace? One is turnaround time. Okay. Second is obsolescence. Okay. Normally, problem comes here that because the aerospace industry is almost, it's not like you can't go for mass production. Okay. So we have to go for standardized operating procedures and process streamlining. Because here, the thing is, each product or each one product may be a different or a unique one. It may require a different components, different parts and all. So that by using the standardized operating procedure SOPs and by streamlining the process, we can reduce that turnaround time. Now, of course, obsolescence cost. Okay. Normally, the technology is going to change, and meantime, the requirement also going to change. So, depending upon based upon the technology changeover, or depending upon the customer requirement, so certainly going to be lots of obsolescence. Okay, outdate thing may come here. So, by managing the spare parts, okay, by spare parts management, they can solve the, or this problem of obsolescence cost can be eliminated. So these are the common issues related to automobile and aerospace. Okay. Now it's very important to know about Lean and Six Sigma. Okay, Lean and Six Sigma. I told that is there are two pillars in just-in-time, pillars of lean manufacturing at TPS, just-in-time concept and Judoka. Okay, so now just-in-time focusing on how much required, when required, time and quantity. Judoka says that quality, zero quality, but defective product should not go out of the organization, should not reach the customers. I told during that time that is zero defect concept, nothing but the Six Sigma component. So it is manufacturing, or there may be one defect out of millions of components manufactured. That's what Six Sigma says. So now we are relating that lean manufacturing and Six Sigma. These are two concepts. Lean improves the flow by eliminating waste. Here, lean basically improves the flow by eliminating waste, overproduction, space utilization, movements, okay, scrap reduction. So there are so many wastes. So basically lean focuses on eliminating waste. Six Sigma improves the process by reducing variation. Okay. So normally in SQC, statistical quality control, we say that Three Sigma limits. Okay. But here it says Six Sigma limits. That is trying to focus, narrowing the process. So trying to reduce the variation. Okay. Six Sigma mainly focusing on improving the process by reducing variation. So reduction in variation, reduction in waste, eliminating. Okay. Combining lean with Six Sigma results in smooth and steady flow. That's why they say that. So both should go hand in hand. Lean as well as Sigma, because lean focuses on eliminating waste. Six Sigma focuses on reducing the variation. Means suddenly the reducing variation means there is no quality variation. Input going to be quality one only. I told now same thing. It can be okay. Even though we say always say that zero defect concept, but still, if at all there is any error comes or if defect comes, it should be around one defect out of millions of components, 1 in million components. Right? So you just combine this Six Sigma as well as lean. Okay, so combining lean with Six Sigma results in smooth and steady flow. You can see that how smooth. You can see that they have shown that a road, okay, where you have a smooth and steady flow. You don't have to apply clutch or a brake when the road is like this. When there is when the road is tight, there is no humps. Okay, you can apply. Suddenly you can say that even the flow also right and waste is also there, not there. So you apply more clutch, more brake, then ending with, of course, consumption of fuel. So suppose imagine that there is no hump, there is no humps or nothing to brake, there is no turn around. You have a straight, smooth road, then no need. No, so I can say it. So this is the road. It's due to that. We can say it, by combining Six Sigma and lean, so you can have that smooth flow. Okay, smooth and steady flow. That's why this has shown. You, for example, you can say it here. Sometimes I think in MIS they say it waterfall model and all. Okay, so see it improves the flow by eliminating waste. See, absolutely, the flow is there. Okay, there is nothing hindering the flow of water. It's falling, no wastage. Okay, that's why they shown that waterfalls to improve the flow by eliminating waste, no waste. Okay. Next, by all these things, right? So now, sorry, I can't show you complete this one because of some problem. Yes. You can see here, it's not hard work, it's work smart. Methods to increase productivity. Okay, why we do lots of things about, why you discuss lots of things about lean manufacturing and just in time, Judoka, okay, Six Sigma, and these are various concepts have been come. Okay, why? Basically, to improve productivity, these things are required. Okay, all these concepts are required to improve productivity. That's why we can say it. Let's work smarter. Focus on lean. Focus of lean. Right. Say now, the question is how to increase productivity. It's the main problem, our main issue, our main focus of any organizations are it is how to improve productivity. Productivity improvement. They do lot many things to improve productivity. Okay. That is how to increase productivity. One, you can go for either quantitative approach or you can go for qualitative approach. Two approaches. Either you can go for quantitative or you can go for qualitative approach. Two approaches. What do you mean a quantitative approach? It is quantity. Employ more staff, okay, more staff, more machines, work longer. Okay. You want the productivity, you want more production. Okay. Employ more staff members, more workers, laborers, staff basically, and buy more machines, and then work longer. Okay. Increase the duration of working hours. So work more. So can improve productivity. Right now, so that's a quantitative approach. You have more quantity, corresponding to that you want more production. Qualitative approach, okay, work harder. Instead of going for more number of workers, with the limited workers, we can say it, work harder, okay, effort utilization of the time, work harder, and eliminate waste and simplify. Okay, so that's what apply lean, eliminate waste and simplify. Right. Then we can improve productivity. So instead of going for working for a longer time, work smarter. It's not how long you work, it's how smart you work. That is called, that's what, sort of one method of improving or increasing productivity. Okay? So repeat once again here. There are two approaches to improve productivity. One is either quantitatively or qualitatively. Quantitative basically focusing on employing more staff, more machines and work longer. Whereas qualitative approach say that work harder and eliminate waste and simplify. So that's what you can say that work smartly to improve the productivity. Yeah. So here we can say to focus here for improvement. Okay. Work for work and waste. Okay. So here two things are there here. One is value added. Okay. Value added. Value is not going to waste. Okay. Anything is going to add value for the product where customer willing to pay for it. Okay. It is value add only. So the question of waste won't come into picture in value added. Whereas in case of non-value added, okay, you can say there are two wastes. One is pure waste. Second, incidental waste. Okay. Normally they're going to be, of course, almost both are same amount of waste are going to be, but we can say here where you can focus for improvement. See, these are incidental wastes. It occurs immediately, or maybe instantaneously, or incidentally. Say, for example, while manufacturing, suddenly, due to voltage fluctuation and all, okay, a tool maybe moved fastly or something like that, or maybe machine power not properly worked. That time maybe end up with some sort of small defects may come. Okay, so that is not expected, incidentally happened. Okay, so no one is responsible for it. Or likewise, so suppose while transporting the end product, okay, so while distributing or transporting or material handling and all, that time chances of having some sort of what you call as defect may occur or some thing may happen to for the product. So that is incidental. So that waste can't be avoided. So it's non-value added, but non-value added only, waste only, but incidental, you can't avoid. Whereas there are some wastes, okay, they are pure waste. Okay, so here focus need to be here. That is where you won't have a pure waste. So here you have to focus for improvement. Okay, focus only on non-value added. In non-value added, once again, you have to focus on pure waste and non-value added, that is incidental waste. Anyway, incidental waste, thereby accidentally it happens. You have no control over this incidental waste. So there are some waste that can be controllable from the hands of the operator or the persons involved and all. So that can be avoided. So if you want improvement, then you have to focus on this non-validated pure waste. Yeah, it's work versus waste. Next here, when you say that when you're differentiating value added and non-value added, okay, which are the activities are called value added, which are the activities called as non-value added. Okay, so we said there are some pure non-value added and there are some incidental non-value added items are there when you're thinking of improving productivity or when you're focusing on improvising. So, but if you know first of all, which are the activities called as value added, which are called as non-value added. Okay. Value added activities, an activity that changes the size, shape, fit, form or function of the material or information. Okay, anything that is converting the raw material into end product, which is required for functionality purpose. Okay, that is of course required. Any processing to be done on a product while converting from raw material to the end product. Okay, that is, you can say they are the activities. For example, changing the size, shape, and fit, form, and function of material or information. Okay, that is activity required for converting from raw material to the end product. Okay, that's a required activity. It's value added, and the customer wants it. Okay, sometimes to meet customer requirement. Okay, there are some of the functionalities required by the customers. Okay, so they may require, for instance, in a bike, a two-wheeler bike, wherein all the regular spare parts are essential. Say, for example, horn or side mirrors, and comfortable seats, and sari guard, and mud guard, and likewise you may have so many small components or spare parts are there for a bike. Okay, but sometimes they're going to be one of the small handle they're going to provide. But I observed in two-wheeler, we are going to have small handles. That is basically for the pillion, the person sits behind the rider to hold it, or sometimes when you're going on a single ride, so sometimes to tie some of the goods also back. You might observed the two-wheeler rider, either to hold firmly by the pillion or to tie something. They're going to add some extra component, customer requirement. Okay, sometimes anything extra added. Okay, that's also a customer requirement only. It's value add only because we're going to add value to the customers. Customer want it. Sometimes they're going to see whether it's there or not. Okay, and then right the first time. Okay, anything, any operation, any process done in the beginning for the product. Okay, that's value add only because it was inevitable. So for example, before any component is in the raw stage, so it has to be machined or it has to be cut to a proper size. Okay, and then it has to be bought. So we can't say that that is trimming, all those things are non-value added because it's required. Say for example, a granite or a big stone, you want to bring only sides and all. Okay, that time what they're going to do, they're going to take a bigger granite rock, then they trim it, they bring it to size. Then they're going to go for all tiles and all, granite tiles and all later. So it does not mean that these are the only things which are value added, which are done to trim it for loading purpose and all. They are not. They are also value added because only when they trim that unsized or awkward or oversized component for the required component, then it's bought for operation. Okay, so that is one of the value added only. So we can say that value activities are any activity that changes the size, shape, and fit, form or function of the material or information is called value added activity. And also sometimes to meet customer requirement, customer wants it. And of course, any activity which is done right in the at the first time only, so they are called as value added activities. And the non-value added activities, instead of and all, I will discuss in the next class. So today I focused on this lean management framework and also two pillars of lean manufacturing systems and the various environment like services, process industries and manufacturing. Meaning lean manufacturing is not only applicable to manufacturing but also various other environments like process industries, service sectors and the manufacturing. And of course, how that manufacturing and what's look like. So shows some application, automobile, whatever, as well as aerospace, and relating the lean and Six Sigma, why they are important, and of course, where you have to focus, where you have how to improve productivity, where you have to focus with this graph. So we'll continue next class.